Okay, we're going to go through the Chapter 2 review. The first question, any of these graphing questions, notice that they have a Part A and a Part B. So Part A is just graphing the parabola, and then Part B is answering some of these questions. And really, I probably should switch these in the future because you really kind of need to fill in these blanks in order to do the graph. So we're kind of going to jump between the two. So we've got the equation y equals 2 times x plus 3 times x minus 1. This is intercept form. So our x-intercepts are -3 and 1. And I am going to, on the test, give you a piece of paper that has some blank graphs on it so that you can start kind of sketching this on your own. So here's -3 and 1, because if you try to sketch it like this, it's just not very accurate, and if you have some blank graphs, that'll make it a little bit easier to sketch. Halfway between -3 and 1 is -1. So our axis of symmetry is at -1. So down below, our x-intercepts are -3 and 1. Halfway between -3 and 1 is -1. So our symmetry line is at -1. And our symmetry line is always the first part of our vertex. So I know that my vertex is -1 something. I'm going to plug that -1 in to get the y value of the vertex. So 2 times -1 plus 3 times -1 minus 1. That would be 2 times 2 times -2. Now, do you see how when we plugged that in, you got +2 and -2, those matched, but they're opposites of each other? That should always happen. If it doesn't, that's a sign that maybe your axis of symmetry isn't correct. You may want to go back and check it. 2 times 2 times -2 is -8. So our vertex is -1, -8. Okay, here's how you graph the parabola. So you click this little button that says parabola, and it's going to put a random parabola up here. One of the points is the vertex. The other point is just another point on the parabola. It can be an x-intercept. It can be a y-intercept. It can be any other point that you know is on the parabola. So I know that my vertex is at -1, -8, and it looks like 6, 7, 8. So right there is -1, -8. Then I know that another point is at the x-intercept 1. So I could put this at the x-intercept 1. I could also put it at the x-intercept -3. It is going to make that symmetrical graph for you. So in order to graph a parabola in EdSite, you need to have a vertex and then one other point. So if it's in intercept form, you've got 2 intercepts, pick one and put that in, but you definitely need to have your vertex in order to graph the parabola. So really, if I were you, I would write this equation down on your paper and then scroll all the way down and answer these questions, fill these blanks in before you try to put the parabola on the graph. Okay, this next one is in vertex form. Y equals -2 times x plus 1 squared minus 3. So we can identify right now that our vertex is at -1, -3. Remember, the part of the vertex inside the parentheses is always backwards. So +1 inside the parentheses actually means -1. So again, I would scroll down to the bottom. I know my vertex is at -1, -3. And that means my axis of symmetry is at -1. Okay, so I know my vertex is at -1, -3. That's like down here somewhere. I don't know another point. You're going to have to pick an x value and plug it in to get another point. So I'm pretty close here to 0. I'm going to pick the x value 0, plug that in, and see what I get. So -2 times 0 plus 1 squared minus 3. 0 plus 1 is 1, 1 squared is 1, and -2 minus 3 is -5. So I know the point 0, -5 is on the graph. So now I have my vertex and one other point. That's what you need to graph in EdSite. So I click this button, and it gave me a really weird parabola there. Whew. My vertex is -1, -3. And then another point, so grab this other one, is 0, -5. That says -6. Be careful. A lot of people miss that because of how it's labeled. I may go in and change this so that it's like so that maybe the graph, instead of going from -10 to 10, maybe it goes from like -7 to 7, so that hopefully it changes that, because that little 6 is so small it looks like a 5, and I think a lot of people mess that up. So be very, very careful that you are truly getting that point at 0, -5. A kangaroo's jump can be modeled by this equation where x is the horizontal distance and y is the corresponding height in feet. Anytime I have problems like this, I like to draw myself a little picture. So here's the kangaroo's jump. This is vertex form. Vertex form tells me the vertex. This vertex is 5, 2.5. Now, what does that mean? That means from this point to here is 5. And so from here to the end is also 5 because it's symmetrical. So what is, oh, we haven't gotten to that question yet. Then the other thing that that tells us is that from this middle point all the way up here to the top, that is the height 2.5. So when they ask, what is the maximum height of the kangaroo's jump? They're asking you for the maximum value. The maximum value is 2.5. So this word problem is actually super simple because the equation itself tells you the maximum height. How long is the kangaroo's jump? It's 5 feet into the vertex, 5 feet from the vertex out to the other side. So the kangaroo's jump is 10 feet long. Okay, this question is very similar, but one of the things that you need to notice is the equation has a y-intercept. -0.3x squared plus 3x plus 10. This plus 10 is your y-intercept. That means that the graph is going to cross the y-axis at 10. And then it's going to look something like that. That might not be very accurate. Sure. The path that a motocross dirt bike rider follows during a jump is given by this equation, where x is the horizontal distance in feet from the edge of the ramp and y is the height in feet. So this motocross driver is riding up this ramp and then goes off of this ramp and then completes the jump. So this portion, he's on ground. He's driving up the ramp. So what is the height of the ramp? Well, the ramp is right here. We already figured out that that's 10 feet. So the first part of this example is very, very easy. It's the y-intercept. What's the height of the ramp? It's the y-intercept. What is the maximum height of the rider during the jump? To get the answer to that, we need the vertex. The vertex, the y value of the vertex is going to tell us the maximum height of that jump. To find the vertex from standard form, you need to do x equals the opposite of b over 2a. So in this case, -3 over 2 times -0.3. 2 times -0.3 is -0.6. And -3 divided by -0.6 is 5. So I just figured out that the x value of the vertex is 5. To get the y value of the vertex, we need to plug it in. So -0.3 times 5 squared, that's not very clear, plus 3 times 5 plus 10. I am going to let my calculator do all of that work for me. -0.3 times 5 squared plus 3 times 5 plus 10. 17.5. So 17.5 is the maximum height of that jump. Sorry, I've totally got off of, there we go. 17.5. Okay, those 4 questions were honestly the hardest questions on this review. The rest of this is just talking about domain and range and match the function to the parabola, and then there's a couple of data tables at the end. So I'll see how much I can get done in the 5 minutes I have left of this video. Okay, this one, the domain. The domain is always all real numbers. Grab it with your mouse and drag it into that blank. The range is, this is a maximum value, so it has to be less than, and range is always your y's. So anything that says x, ignore it. Y is less than or equal to 4. What is the range of this quadratic function? It opens upward, so it has to be y is greater than, and the y value there is 4. So it's either y is greater than 4 or y is greater than or equal to 4. We've always done greater than or equal to because that vertex has a y value of 4. So our y values can equal 4. Which function matches this graph? Notice all of these are like the transformations that we did the first day. So this graph is flipped upside down. So I know there has to be a negative in front. All of them do. It is moved left 4. So that one means up 4. That one's a stretch. So is it plus 4 or is it minus 4? Remember, side to side movement is backwards, so left is actually plus. Which function matches the graph? Again, we have vertex form here. Now, I notice that this graph opens upward, so I know it's not going to start with a negative. It definitely looks kind of wide. It does not look narrow like this 3 would create, so I know it's not 3. And I think it's wider than normal, so I think it's probably this 1/3, but let's check the other numbers to be sure. This vertex right here has moved from 0, 0, right 2, down 4. Right 2 would be minus 2, and down 4 is minus 4. So that would be our correct graph, or our correct function. Which function matches the following description? So I'm just going to kind of make some notes. The parabola opens upward, so I know it's positive in front, with a vertical stretch of 2, so I know there has to be a 2 in front. Oh, and it's telling us intercepts, so I know it's going to be intercept form, and I have to put the intercepts in backwards. So 4 actually goes in as minus 4, negative 3 goes in as plus 3. So which one matches that? Positive 2, x minus 4, x plus 3. Notice the order of those parentheses does not matter as long as one of them says x minus 4 and the other one says x plus 3. Okay, the data tables. This one, it's kind of hard to show on here, but really you're looking at how the numbers are increasing. So from 25 to 13, we're decreasing by 12, decreasing by 12, decreasing by 12, decreasing by 12, decreasing by 12. If that first level is the same, that is a linear function. Okay, this next one. From 3 to 5, we are increasing by 2. From 5 to 11, we are increasing by 6. Then 11 to 21, we're increasing by 10. Then we're increasing by 14, and then by 18. So I just looked at like 5 minus 3 is 2, 11 minus 5 is 6, 21 minus 11 is 10, 35 minus 21 is 14, and 53 minus 35 is 18. These are not the same, so I know it's not linear. So now I'm going to check the next level. From 2 to 6, we add 4. Add 4, add 4, add 4. If the second level is the same, that means it's quadratic. If the first level is not the same and the second level is not the same, then you would click neither. But the second level was the same, so it is quadratic. And I believe that is it. Yep. Woohoo, 100%.